Okay, standby, kamera ready, sound ready, 3, 2, 1, action.
Sabrina, did you feel that? It's only 10 a.m. but the heat is already unbearable. Why is it getting so hot?
It's not a heat wave anymore, Hannah. It's a systematic failure result from the old decade technology.
So what? We just accept it?
No, we upgrade it. That's why we are here today.
Welcome to the Green Technology Revolution. Hello and Assalamualaikum. My name is Izahana binti Muhammad Noor.
And my name is Sabrina Najwa binti Anwar. So, for our SCE 523, we are going to prove that technological revolution is not just saving the trees, but it's about the technological shift. How technology save our planet.
We are going to explore together how Malaysia is moving toward net zero 2050 by using energy, mobility and also circular economy. So, let's go find the future.
Green technology, also known as environmental technology or clean technology, refers to innovations designed to reduce environmental impact, conserve natural resources, and promote sustainability. It aims to tackle challenges like climate change, pollution, and resource depletion by focusing on eco-friendly solutions. Key features of green technology: 1. Sustainability. Minimizes resource use and waste. 2. Renewable energy. Relies on sustainable sources like solar, wind, or hydro. 3. Energy efficiency. Reduces energy consumption while maintaining output. 4. Pollution reduction. Cuts down emissions and waste products.
Do you guys know that Malaysia has a goal of 70% of renewable energy capacity by 2050? But I was thinking, how do we get there?
It starts with the photovoltaic effect. It is a process that generates the voltage and electric current in a material upon exposure to light. This principle is the foundation of solar cells, which convert solar energy into electricity. Simple but revolutionary. By solar on your roof, you are not just a consumer, but you are a producer.
How do solar panels generate electricity? Electricity is the flow of electrons around a circuit. In a solar panel, energy from the sun prompts these electrons to start flowing. But how? It's all to do with the photovoltaic cells that solar panels are made from. Photovoltaic cells are made out of 2 layers of silicon. One layer is positively charged and the other is negatively charged, creating an electric field that will enable an electric current to be generated. When sunlight hits the cell, light particles knock some of the electrons within the silicon free from their bonds. These are drawn to the positively charged silicon layer. However, a bridge between the 2 layers only lets electrons cross in one direction from positive to negative. So instead, the electrons are collected by conductive metal plates that move them from the solar cell into a circuit where they flow freely as electricity. This electricity can be used in your home, stored in a battery or electric car, or exported to the electricity grid. Standard solar panels will generate 100% renewable energy electricity for 25 to 30 years.
Oh, so that's how a photovoltaic effect on the solar panels that I have seen on many buildings and houses.
Yes, Sabrina, that's true.
But the revolution is not just a solar. In 2026, we are seeing the rising of green hydrogen. Unlike coal, the only product of hydrogen fuel is water.
How does a hydrogen become a fuel?
It's easy, Hannah. Once a hydrogen produces a molecular hydrogen, the energy present within the molecule can be released. By reacting with oxygen to produce water, this can be achieved by either traditional internal combustion or device called fuel cell. In fuel cell, hydrogen energy is converted directly into electricity with high efficiency and low power loss. Hydrogen is an energy carrier which is used to store, to move, and deliver energy produced from the source.
Hydrogen fuel cells work by converting chemical energy directly into electrical energy through a clean chemical reaction. Inside the fuel cell, hydrogen gas is supplied to one side, which is the anode, and oxygen from the air is supplied to the other side, which is cathode. The hydrogen molecules are split into protons and electrons. The electrons flow through an external circuit, creating electricity that can power a motor or device, while the protons move through the fuel cell membrane. At the cathode, the protons, electrons, and oxygen combine to form water, which is released as the main byproduct. This process will produce electricity efficiently without burning fuel, making hydrogen fuel cells a clean energy technology.
Okay, Sabrina, the energy itself is great, but what about the millions of cars on our roads?
That's where the e-mobility revolutions come in. Look at this charging station. Many people think EV just for the rich, but with the new government's low carbon mobility blueprints 2021 until 2030, LCMB is become accessible for everyone.
The revolution is not just about the cars, but it's about the MRT, LRT, and all those electric vehicles you can see in the center of the city. Every person on public transport or electric vehicles is one less car polluting our air. This action is aligned to what you said before, Sabrina. The blueprint deploys a policy framework to mainstream the shift towards electrification in the transportation industry as a key strategy to diminish our emissions and contribute towards the achievement of our National Paris Agreement GHG target.
As for you guys that are still using a gasoline, driver techniques has a lot to do with your fuel economy. Avoid sudden start, stop, and speed limit. Not just only dangerous and kill your MPG, but also affected the earth.
Speaking of that, EV does not use any stored energy or cause any emission. While idling is capable of frequent start-stop driving, provide the total torque and from the startup, and does not require trips to the gas stations. It does not contribute either to any of the smoke, making the city air highly polluted. The instant torque makes it highly preferable for motorsports. The quietness and the low infrared signature makes it useful in military use as well. The power sector is going through a changing phase where renewable sources are gaining momentum.
As the EV market matures and economies of scale come into play, the price gap between EVs and traditional cars is expected to narrow even further. Section 7, the green factor, environmental impacts of EVs, electric vehicles are widely regarded as a key component of a greener and more sustainable transportation in the future. By eliminating tailpipes emission, EVs contribute to cleaner air quality, especially in urban areas often affected by smoke and pollution. The environmental benefits of EVs go beyond lower emissions. They operate much quieter than traditional vehicles, reducing noise pollution in cities and residential areas. Furthermore, as the electricity grid transition to renewable sources like solar and wind power, the environmental footprint of EV charging diminishes further. However, it's important to acknowledge that the environmental impact of EVs is not entirely without challenges. The production of EV batteries requires significant amount of energy and raw material, which can have environmental implications.
Revolution is not just about making new things, it's about what we do with the old stuff.
We produce many of waste every day. In the old days, we just buried it in landfills. But now, we have waste to energy plants.
Waste to energy. How is that possible?
Yes, it's possible because of the world's requirement for energy will increase by a factor of about 6 times by 2100. Waste to energy is applied especially in developing countries. This approach leads to purification of waste, disposal and also to maximum utilization of energy contained in flue gas.
Oh, I see. But what is the relationship between waste to energy and the circular economy?
Waste to energy is one of the strategies from circular economy. A circular economy reveals and designs out the negative impacts of economic activity that cause damage to human health and also natural systems. This includes the release of greenhouse gases and also hazardous substances, the pollution of air, land, and also water, as well as the structural waste such as traffic congestion.
Once a truck arrives, they are weighed and checked in before heading inside the tipping hall. The waste is unloaded into a tipping floor and visually inspected for any unacceptable items, which are removed for separation, recycling, or proper disposal. Waste is then pushed into a storage pit and thoroughly mixed before being loaded into bins, which we call hoppers, where it travels to the combustion chamber. The tipping and waste store areas are maintained under negative air to contain dust and odors. Once fed into the combust chamber, waste is combusted at extremely high temperatures in a self-sustaining process at approximately 2000 degrees Fahrenheit. A typical hopper load is completely combusted in 1 to 2 hours. As the waste is burned, the heat converts water in the steel tube line walls to steam that rises through boiler tube where it is superheated. The steam turns a turbine-driven generator to produce electricity, or may sometimes be used directly for heating or industrial processes. The electrical produced by the turbine generator is exported to local utilities for use in home and businesses. Each ton of waste can generate 550 to 700 kilowatt hours of electricity. Steam from the process is condensed into water and returned to the boiler tubes, making it an efficient closed-loop system. After combustion, the volume of waste is reduced by 90%, leaving an inert ash and metal. Collected metal is sold to be made into new products. Remaining ash is beneficially reused or buried in landfills as non-hazardous waste. Ferrous metals such as iron and steel are recovered using a rotation drum magnet, and non-ferrous metals like aluminium and copper are separated by an eddy current system. State-of-the-art pollution control equipment ensure that emissions are well below to be fully protective of human health and environment. We neutralize acid gases using lime in a scrubber reactor and inject activated carbon for heavy metal control. We control emission of particulate matter primarily through a baghouse, which employs thousands of fabric filter bags. All fuel gas must pass through the bags before exiting through the stack. Throughout this process, the control room closely monitors emission through a real-time continuous emission monitoring system, controls steam flows, and manages a number of other automated systems inside the facility. Waste to energy inside the facility is widely recognized as technology that help mitigate climate change.
We have seen the revolution and we have seen the technology, but is it enough?
We learned that technology is only half the battle. The other half is us, our mindset and our choice.
We have realized that the green technology is about energy, environment, social, and also economy. So it's about creating jobs while saving the air we breathe.
Malaysia is ready, the policies is there, the technology itself is there. Now, it needs us, the next generation of scientists and educators, to lead away.
So Hana, are you ready for the new version 2.0 of our planet?
I have been ready since the first spring.
Thanks for joining us for this journey.
Be the revolution! Bye!